all have your, oh.
I was gonna just do
So you'll have to complete again, all of this stuff is on Canvas now, so you can go and, except for honor students, I'm sorry, I'm really sorry. All of this is on Canvas now. So if you miss a day, you're responsible for going to Canvas and figuring out what you need to submit to me. Okay, so we had previously created the first two paragraphs of our conclusion. We said this is why this is what we did, and this is what we found. And then we talked a little bit about the important chemistry. Then we said that we need our third paragraph to be about possible sources of error. And I asked you to think about it, at least just sort of in passing maybe, about what kinds of sources of error that you could have related to this procedure. And so let's sort of just brainstorm. What kind of sources of error could I have? Garen, you have an idea?
Lack of integrity in the filter paper.
Okay, lack of integrity of the filter paper. And I'm just going to write some of these down, and then we'll fashion this into a paragraph. Lack of integrity of the filter paper. Okay, and I would suggest that when you sit down to write these things, you're not always going to just be able to poop it out right at the start, without writing some thoughts down. And so you may need to do some brainstorming and figure out how you're going to put these things into a paragraph before you actually write these things. What else might be a source of error? Yeah, Liz?
Not using deionized water.
Okay. Not using deionized water. And I can't spell today. Deionized water. Jonathan, what do you have?
We weren't using like a super specific scale for weighing stuff.
Okay. So a less accurate balance. Okay, and just measurement in general. What else? Karen, you have another one?
Impurities in the minerals.
What's that?
Impurities in the minerals.
Impurities. Is there anything specific that you are aware of that made you think that, or is that just something that you thought of? Okay. In general, things that we're going to use in a high school laboratory are probably pure enough that it's not going to make a lot of difference. The purity of, impurities in minerals, I could make that a little bigger, couldn't I? Sorry about that. But at least it's something we can mention. And Aspen, you had something?
Yes, incorrectly calculating the amount of grams for each one.
So, and how would it be that we would incorrectly calculate that? Just math errors or what?
Math errors.
Okay. Okay. What else, Jonathan?
I guess when pouring the filtrate, like your essence fill out.
I'm sorry, I didn't hear what you said.
When pouring the solution with like the yellow cement stuff into the filter paper, someday it would like down spill out.
Okay. Yeah.
Just lost the substance in general.
Filtration. Sloppiness.
Filtration.
What's that?
No, use but
So obviously I won't use the word sloppiness in my paragraph, but what other things might, there's one that caught my attention that
So if you were to overfill the volumetric class, you have to take some out in order to correct the ratios, which could take out some of the mineral that was being dissolved.
okay, so, solution preparation errors. Okay, now, I would suggest to you, though, that if you were aware that you overfilled the volumetric flask, you would necessarily need to, you would need to redo the whole thing. But, so, not only the volumetric flask, but also the one that I saw a lot was, so far your technique in using the graduated pipettes is not great. Okay, so especially with the graduated pipettes, my thought would be that the difference between 100 milliliters and what you delivered to the Erlenmeyer flask was pretty significant. My guess is that there was probably, I don't know, some instances where it might have ranged from anywhere from like 97 milliliters to 103 milliliters. Partly because it's so easy to lose the especially when you're transferring the pipette from the beaker over to the Erlenmeyer flask. There were a lot of you that lost some water along the way. So, and if you really, really wanted to do it correctly, if you noticed that, you would have to do it again. So anyway, that was one. Now, the interesting thing about this is that the amount of liquid that you put into your volumetric flask or into your Erlenmeyer flask isn't going to change anything in terms of how much of the precipitate you get. Why is that? Yeah, Jonathan.
by the end of the thing, or we're actually testing, like measuring stuff, your evaporating water. It's just the environment for the.
Okay, so there's another factor that's a lot more important than anything like that. Think about it again. What is going to create the amount of precipitate that you actually get? What's going to give you that number of grams or number of moles of precipitate that you actually get? Okay, so does it matter how much water you used in any of this? Okay, it doesn't matter how much water you used in any of this. Your measurements of the water could have been wildly inaccurate, but the reactants, the number of grams, that number of moles that number of grams represents is the only thing that would determine how much precipitate you got. Okay, so if you had 150 milliliters of water in your volumetric flask and 150 milliliters of water in your Erlenmeyer flask, that didn't change the amount of reactants that you had, it just changed the concentration. Okay, the overall amount of precipitate that you ended up in this case with was only going to be determined by the number of moles of reactants. Okay, so even though I made it seem like a big deal, because I want you to think about these kinds of things where you need to be as accurate as you possibly can, that would be one thing that is not going to affect the outcome of this experiment. Okay, so anything that you did related to the amount of water that you got into the solutions is not going to change anything. Okay, it was only the amount of the reactants that determined the amount of the precipitate. Now, it is important that you still do that correctly, because the amount of the concentration, the molarity of the thing, was what allowed you to determine how many grams you were supposed to use in the first place, right? We had our chemical equation here. We said lead acetate plus 2 potassium iodide. Okay, the only way that we knew how many moles or how many grams to use in the first place was because of the molarity that I gave you, right? You needed to make a 0.1 molar solution of each of these things, or 0.1 molar of that, 0.2 molar of that, and that multiplied times the volume was what allowed you to figure out how many moles of substance you needed, and that's what allowed you to figure out how many grams that was. So in your understanding, it's still important that you try to make this as accurate as possible. So Garen wants to blame their group's error on the integrity of my filter paper, not anything they did.
No. I don't want to blame my group's error for getting stuff on our fingers and putting it on the side of it. Our filter paper was fine.
Oh, well then how come you said lack of integrity of the filter paper?
Because I noticed other people.
Okay.
Cloudy substance.
Okay, now how come you didn't say what you just said?
I did. Or someone else did. When,
Yeah, I said the filtration is helping us. I was.
Yeah.
Okay.
Right.
Oh, I see what you're saying. Okay, the filtration sloppiness that you were talking about, when I think about that, I think about the fluid actually spilling over the top of the filter and then material getting down into the filtrate that shouldn't be there, and you're losing material that way. But obviously, if you were messing with the filter and half of the precipitate got all over your hands and that didn't get into the, so hopefully you washed your hands.
Yeah.
Okay, because this does have lead in it. Okay, so is there, and I guess I would also say, as far as math errors go, in something like this, it's assumed that you're not going to make math errors, okay? It's assumed that that's not going to be something that gives you a bad result. Because if you get a bad result, chances are good you're going to go back and check your math. And it certainly wouldn't be something you would want to tell somebody about, okay? If you were to put that into a communication, as much as we sort of frown on bullying people, you would get a lot of ha ha ha, you can't even, that kind of thing. So it's certainly a potential source of error. It's not something I'm likely going to put into my conclusion though. So, but and it's a good point, but those are things that we would probably try our best to rule out. I remember. Any of you watched The Big Bang Theory? A few of you watched The Big Bang Theory. There was an episode where Sheldon submitted a paper to Stephen Hawking, and he had made a math error in the paper that he submitted to Stephen Hawking, and it was impressive, the reaction when he figured that out. He fainted. So, yeah, these are things we try not to tell other people about. So we might let other people see that we've made math errors, but we certainly wouldn't publish it. Let's see. So I'm not gonna, although that's a good idea, I'm not gonna put that in there. So this is something that's its own error. What do all of the other, and this is something that its own error, impurities in the minerals, what do all of the other errors relate to? Errors in what? Yeah, Aspen?
Manual errors.
Okay, so, or errors in technique. Okay, so a lot of these things are errors in, why are you doing that? Errors in procedural technique. So one approach to this paragraph would be, since so many of these things are errors in technique, is that you would make a general statement, a first statement about most of our errors appear to be errors in technique. For example, and these are things, and if for the more significant ones, you might want to say how it would affect the outcome of this. And all of these would have affected the outcome in that it would have decreased the amount of precipitate that you actually ended up getting. So that's kind of the thing that we would want to focus on. The other two, the not using deionized water and impurities in minerals, we would also have to explain, but they would be kind of their separate thing. So let's see how we might start something like this. First of all, we would want to say, we observed a percent yield that was significantly less than what we would anticipate. Okay, were any of your percent yields over 90%? Okay, for this kind of a, was it this class or the other? Was it this class that asked about what would I have expected for this?
Yeah.
Okay, and I think I would have said somewhere close to 100%. We should, if our technique is good, we should have been able to get pretty close to 100%. We observed a percent yield that was significantly less than what we would anticipate. So we're stating that right up front. There are several possible sources of procedural errors. Okay, there are several possible sources of procedural errors. And let's say, the most significant of these probably related to filtration procedure. So to my mind, that would be the point where you would get the most possible loss of substance. Okay? The errors that we might make in the balance are not going to be that significant. A few tenths of a gram, or a few hundredths of a gram, or even a few tenths of a gram are probably not going to make too much difference in the amount of precipitate that we get. The point where we're going to lose precipitate or lose the amount of precipitate that we're going to recover is probably going to be in that filtration step. Okay? And so, let's see, how do we want to say that? The most significant is probably related to filtration procedure. These errors would include, but may not be limited to, spillage of precipitate over the edges of the filter or improper handling. Yeah.
Thank you.
Or improper handling of the filter apparatus. Okay, of the filter apparatus. So these errors would include, but may not be limited to, spillage of precipitate over the edges of the filter or improper handling of the filter apparatus. One filter was also noted to develop a hole allowing some precipitate into the filtrate. Okay, by the way, that's what the stuff that went through the filter is called. It's called the filtrate. The stuff that we didn't want to keep is the filtrate.
It's a fancy way of saying somebody accidentally poked a hole in it and now it got all over.
Yeah. Is that what yours was?
No, it's just
That's what mine was.
the general idea of it.
Yeah. Okay. One filter was also noted to develop a hole, allowing some precipitate into the filtrate. Yep. Okay. So, I mean, I think that's the most significant thing. Other errors in technique might include errors in massing the reactants, other errors in technique might include errors in massing the reactants, errors in solution preparation, actually let's say and errors in solution preparation. But these were not likely significant. One other possible source of error was that we did not use deionized water. This resulted in loss of an unknown amount of lead ions due to lead chloride precipitation. If we were to repeat this, we would focus more on proper technique and use deionized water. Okay, that's a lot. I think it covers most of it though without getting so much into detail that you need to have a balance between how much you put down and how much you sort of leave out. And I think this is a pretty good balance. And at the very least, it's a model for you to use for future laboratories. Is there anybody that really thinks the way that we said something here is poorly written, or would rather say it another way, or would also want to add something else in, or is this, you think, satisfactory to communicate to the world? So, and again, you're trying to communicate to your company, you know, what you might do to improve things if you were to follow this particular procedure in the future. So, other thoughts about this? This is along the lines of what I would hope by the end of the year that you would sort of be able to write out for a lab report as far as the sources of error. Anyone still writing? Yeah, Aspen.
I'm kind of confused of why we're writing in the first person. I know you explained it before, but.
Oh, so, and I don't know how other teachers are teaching you to write lab reports and things like that. It used to be that science communications were supposed to be written in a third-person passive kind of voice. And that's really sort of gone away for a large part. If you read a lot of scientific publications in more modern times, in the last 10 or 20 or 30 years, there's a lot more of the first person. We did this, we did that. And I'll be honest, it's a personal preference of mine. Again, you strike a balance between, I don't know, what's more readable versus what sounds more sciencey. And I agree that it sounds more sciencey to say, it was done that, or the procedure was followed in this way, rather than to say we did this. So it really is somewhat of a personal preference of mine. When I wrote articles, when I was at the University of Utah, all of my articles were written in the first person. So if you really feel compelled to write in a third person passive voice, by all means, go ahead and write that way. Nobody's gonna make fun of you, or nobody's gonna say you shouldn't do that. But it's a lot more acceptable to write in the first person now, and that's something that I would just prefer to do. But I'm not gonna grade you based on what person you write your stuff in. So if you want to write in the third person passive voice, by all means, go ahead and do that.
Why wasn't it more accepted before of writing in first person than it is accepted now?
I don't know. I think philosophies about what's acceptable change over time, and our society is a lot more egocentric now than it used to be, and people like to hear themselves say I did this rather than it was done this way. That's just my guess. I don't really know. I don't know, but that might be an interesting thing if you're interested. I don't know, you might Google, is it acceptable to write scientific literature in first person or something like that, and maybe somebody cites a reference that does a review article on the change over time, So there's probably a resource out there that would address that if you wanted to. But from my perspective, but if you've got other teachers that are saying, you need to write in a third person passive voice, do what they ask. Don't go and say Marshall says that it's okay to do this. Then you'll get me in trouble. Yeah.
I guess you could just throw it pretty awesome, write all of your science papers in second person.
That would be weird.
You did this.
Yeah.
Good job.
You did this. That's a really interesting question, though, and my wheels are starting to turn, and I'm wondering if I might just make a little bit of a research project of that myself to find out. There's entirely every possibility that I'm wrong. I don't think I am, but there's always a possibility that it's not as acceptable as I thought that it was. Okay, so our last statement, our summary statement In summary, okay. In summary, we completed a laboratory investigation in which we determined percent yield of a chemical reaction. Okay, here's where you're going to be more general. We don't want to repeat all the details that we've already said. We just want to be more general. In summary, we completed a laboratory investigation in which we determined percent yield of a chemical reaction. During this investigation, we learned techniques of solution preparation separation of components of mixtures During this investigation, we learned techniques of solution preparation, separation of components of mixtures, and identified possible sources of error. In summary, we completed a laboratory in which we determined percent yield of a chemical reaction. During this investigation, we learned techniques of solution preparation, separation of components of mixtures, and identified possible sources of error. We feel that these skills will be and actually I'm going to add something in here. So you'll need to draw a little arrow. Although this was a contrived investigation. What do I mean by that? Contrived. What do I mean by that? Although this was a contrived investigation.
Yes. Is it a group project?
No?
Was it, it's kind of like it didn't actually own much of it.
Yeah, it's not.
Brand new. We've already gone the past.
It was in the
Yeah, it wasn't something that actually accomplished anything scientific, right? people already know that you should get a good yield of this in the real world. This is something that's it's been done before. It's not something that we're adding information to the scientific knowledge base, right? So this was a contrived investigation. We feel that these skills will be useful to us in future lab activities. Okay, so it's okay in this kind of a setting to say, we understand that Marshall just created this for us to learn some other things. So anyway, that would be the last sentence, and that would be kind of the way that you would construct that. In summary, we did all of this in general terms, and you want to say something about the significance of it. Okay, you want to say something about how was this laboratory significant to me, and my hope is that going through the laboratory gave you some skills that will be useful in your future lab activities. Okay. If you actually feel that way, another way, if you feel like it was totally useless and totally pointless, say that. This was a lab activity that I felt didn't add anything to my knowledge base or my skills, and I wish Marshall wouldn't have done it. That's entirely okay to say too. Okay, so this is a place where you can be honest with me, and I'll take it to heart. But anyway, if you felt otherwise, say that. So after all of this, I haven't really done this kind of instruction in quite this way before, where we've gone into this much detail in trying to instruct you in how to write up a laboratory and make sure you understand how to create a procedure. But I really want you to be the ones in the future that are actually doing these investigations rather than me just telling you what to do, and that I've given you enough of a basis to sort of figure things out on your own when we go into the laboratory in the future. Like I said, don't worry about it being perfect at this point. What we've written here isn't perfect, and I'm sure if I did this for myself, I would sit down and I would perseverate about it, and I'd spend all kinds of time trying to make sure that the right word was in the right place. But that requires a lot of experience, and that's not something that you can get in a high school chemistry lab. So I don't feel bad about having spent so much time on this. So hopefully this will go forward. What I would like you to do is simply give me all of the stuff that you have related to this as kind of a packet, not just this paper, but all of the papers that you've written stuff on. And if you were here, so if you were here for all of these sessions, right from the first part, yeah. If you were here for all of these sessions right from the first part, yes. Everything you've written stuff on, and that first packet where we talked about solutions.
Like the other solution lab?
Yeah. Yeah. And if you need to like get it at home, that's okay too. Yeah.
Online, so like piece of paper that you had to do the paper first on, you told us only one way how to do it. If we don't have that paper.
That's fine. I'll recognize that. Yeah.
This is great, but I left my other papers at home, so I left down all of them.
Okay.
Do you want me to try to attend?
No. So here's what, if you need to gather more papers from home, give it all to me next time. Don't give me an incomplete packet and then give me something else later on.
Wait, so what is?
Okay, so
This be all of it? That's what I thought. And I have to take the care of these little solutions. Well, because we have
and
four
so
of them.
what was the one packet that,
Can you show me that on?
those solutions?
Or the backside?
No, not that.
That's the big.
Yeah, solubility.
I don't think you did. I do what you did.
Okay, if I have that, then,
Yeah, we sure did.
oh, did you? Okay. So everything then just for the precipitation laboratory. Okay? Yeah,
Wait, so don't forget it.
yeah, those two, but, okay, but,
Do you have a stapler?
No.
yeah, yes, that's right. Yeah, go ahead and turn that in. Yes. Yes.
I think I did.
And if I think that there's something missing from your packet, I'll let you know. If you are not here for some of these, I will ask you to go on to Canvas and read, and do the.
I don't know. Take it up.
Are we what?
I think it's keep on fingers.
Oh, we rather not.
Yeah. We can fix, I don't know.
So,
There's a button.
like that. We should have a video on.
Here's like this, like.
Oh, okay.
I know. That is actually a high school sport.
Use, right?
Yeah. Oh,
So you guys play there? You guys play
okay, so you guys are gonna wait until you get to your other stuff. Oh, okay, well, leave
Maybe, I
it.
don't know, I heard Olivia
Did I get everyone? Okay. We need to create a test. Well, now if you're creating it though, isn't that a good thing?
No.
Yeah, I don't like guaranteeing.
Well, you're creating it with guidance, you know, but obviously we're not gonna finish this. Yes. We're making a test for.
There it is.
And I'll take what we come up with and put it on Canvas.
Like next year, I just.
Really? Like it's not going to be over by July. They want to start in there and we can start from like them with power.
I think we should just get rid of it.
They don't come out.
I think we should go more creative.
Yeah. Oh, I'm sorry. And you even yelled at me and I just sort of heard you, but I didn't.